Today we're looking at some math essentials for physics class. One of the essentials that we need is knowing how to work with polar coordinates. Polar coordinates use a radius and an angle to define a location on a coordinate plane. Some characteristics are that a positive radius is going to move outward from the center in the positive x direction, that is horizontally to the right. A negative radius moves outward from the center in the negative x direction, that is horizontally to the left. A positive angle starts from the positive x-axis and moves counterclockwise around the circle. And a negative angle starts from the positive x-axis and moves clockwise around the circle. Now, because both the radius and the angle can be either positive or negative, any point can have multiple sets of polar coordinates. So what we're going to do is we're going to use some graph paper and we're going to graph the following points. The first point that we're going to graph is the ordered pair 3, 120 degrees. The first coordinate is the radius. It has a radius of 3 and it's going to go at an angle of 120 degrees. So let's see how that works. Starting at the center at the origin, we move out along the positive x direction, that is horizontally to the right, 3 units. So 1, 2, 3. This is our starting side of our angle. We're going to measure our angle from here, and we're going to go up to 120 degrees. So we're going to follow that radius of 3 all the way around to 120 degrees. And that is our point. There we go. So that's point A. Our next point is point B. It has a radius of 6 and an angle of 310 degrees. So again, we're going to start by counting out from the center 6 units. And we're going to move around the circle counterclockwise to 310 degrees. So as we move around, we keep going until we reach 310 degrees, which is right here. And this is the coordinate or the location of point B. Point C has a radius of 5 and an angle of negative 120. Since the angle is negative, the direction we're going to move is clockwise instead of counterclockwise. So let's start with our radius of 5. And then we're going to move clockwise 120 degrees. So let's kind of go through here and see what that looks like. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, and 20. This is our point C. Notice, by the way, that we could have gotten to point C by moving clockwise instead of counterclockwise. We could have come out to radius 5 and moved around the circle counterclockwise 240 degrees, and we would have ended up in the same place. Let's take a look at point D now. D has a radius of negative 3 and an angle of 60 degrees. Again, this angle here is going to be moving counterclockwise. With a radius of negative 3, though, instead of moving in the positive x-axis to start with, we move in the negative x-axis. So we go to the left, 1, 2, 3, and then we're going to go counterclockwise 60 degrees. So 10, 20, 30, 40, 50, 60. And there's our point D. Point E has both negative radius and negative angle, so we're going to move to the left horizontally to start with, and then we're going to move clockwise 45 degrees. So let's start at our origin, at our 0, and move to the left 5 units. And then we're going to go clockwise 45 degrees. So 10, 20, 30, 40, and 5 is going to be right in between these two. And this is our point E. Notice, by the way, I could have gotten to point E by moving positive radius of 5 and then counterclockwise, that is a positive angle of 135 degrees, we would have ended up in the same place. Okay, so that's plotting polar coordinates. Now, another thing that we can do with polar coordinates is we can switch them back to the standard rectangular XY coordinates, and we do that by using trigonometric identities. What we know about trigonometry is on a circle centered at the origin with radius r, the sine and cosine functions are just defined as the cosine of the angle is x over r, and the sine of the angle is y over r. And if we solve these equations for x and y, we get, multiplying here both sides by r, we get x is equal to r cos theta. And on this one, multiplying both sides by r, we get r sine theta is equal to y. So these are the two rules or formulas that we're going to use to go from polar coordinates to rectangular coordinates. So let's do a few examples for that. We want to convert the coordinates of points A through E to the rectangular coordinates. So to get our x coordinate, all I need to know is the radius and the angle. So let's do that. X is equal to the radius, which is 3, multiplied by the cosine of 120 degrees. So we can do that. We can pull up our calculator and we can look at that. Notice on our calculator, on the mode, we're going to make sure that our mode is in degrees, and it is in degrees. So we're going to quit from that section, and we're going to take 3 times the cosine of 120 degrees. And our x-coordinate is going to be negative 1.5. Then we're going to do our y-coordinate. Y is equal to the radius times the sine of the angle. So y is equal to 3 times the sine of 120 degrees. Again, we're going to do that on a calculator. So we're going to go 3 times the sine of 120, and we get 2.60. So we have an ordered pair here, the x-coordinate negative 1.5 and the y-coordinate 2.60. Okay. Let's do our next one, radius of 5, angle of negative 120. So the x-coordinate, the radius of 5, times the cosine of negative 120. And the y-coordinate, radius of 5, multiplied by the sine of negative 120 degrees. Okay, so let's do those. We have 5 cos of negative 120, and we get negative 2.5. And for our y-coordinate, we have 5 times the sine of negative 120, and that gives us negative 4.33. So our ordered pair is negative 2.5, negative 4.33. Okay? Those are pretty simple. Let's go ahead, let's just do A and C, and let's skip those other two because we know how to do those. Now, rectangular coordinates can also be converted to polar coordinates. And in this one, we use the trigonometric identity that the tangent of theta is equal to y divided by x. So solving for the angle, we get theta is equal to tan inverse of y over x. Since the tangent function repeats every 180 degrees to get points on the left side of the circle, whenever the x-coordinate is negative, we need to add 180 degrees in that situation. So our two rules that we use is that the angle is equal to tan inverse of y over x when x is greater than 0, and it's equal to tan inverse of y over x plus 180 degrees when x is less than 0. And then to find the radius of the circle, we just do x squared plus y squared is equal to the radius squared, which is the equation of a circle. Okay, so let's use those rules. We're going to use those rules to convert the following polar coordinates, or rectangular coordinates, to polar coordinates. And then we're going to graph them and see if it makes sense. See if it looks like the right point on our graph paper. So first, let's go ahead and convert these and see how we're able to do that. Our angle theta is equal to tan inverse of y over x. And so in this case, theta is going to equal tan inverse of 6 divided by 3. And of course, 6 divided by 3 is just 2. We're going to use our calculator. It's going to get an angle back again. When we did sine and cosine or even tangent, if we hit the first function keys, we put in an angle and we got a ratio out. When we use our second function keys, we're going to enter that ratio and we're going to get an angle back. So second function tan, and 6 divided by 3 was 2, so we have 2, and that's 63.4 degrees. So our angle is 63.4 degrees. Now to find our radius, we use the equation of a circle, x squared plus y squared equals r squared. So we're going to use our x and y. 3 squared plus 6 squared equals r squared. So we have 9 plus 36 is equal to the radius squared. So the radius is going to equal the square root of 45. We can leave it as a square root, or we can come up with a decimal approximation. The square root of 45 is 6.71. So our polar coordinates are 6.7 and 63.4 degrees. Okay. Let's do another point. This is the point 40. Again, we're going to be looking at that one. And this one is kind of an interesting point. Before I go ahead and do that, let's go ahead and take a look at graphing. If I want to graph the point 40, this is an x and a y coordinate. I'm going to come here, out here on the x-axis and the y-axis. The x-axis goes through 0, the y-axis goes through the 90-degree angle and the 270 angle. The point 40 would be right here on the x-axis. So as we look at that, we can see that the radius is 4 and the angle is 0. We haven't moved from the x-axis. So in a situation like this, we really don't need to use any formulas. We can just write down where we are. So in this case, we had a radius of 4 and an angle of 0 degrees, and the polar coordinates look exactly like the rectangular coordinates because an angle of 0 degrees here. Okay. Let's take a look now at our point 36 and compare it with our polar coordinates that we got here. So 3, 6, we're going to have to just estimate where 6 is approximately. So we go out here 1, 2, 3. So we're at this point horizontally. Vertically, we're up at 6. So 1, 2, 3, 4, 5, 6. So we're going to come out here and see where those two meet. 1, 2, 3, excuse me, right about here. And this is our point 3, 6. Let's see if the polar coordinates match it. The polar coordinate says we needed to be at point 6.7 and 63.4 degrees. So 6.7, 1, 2, 3, 4, 5, 6.7. And our angle again was 63 degrees. So we move up to 63 degrees and there we are. Okay, so that works. All right, let's convert a couple more so we can see how that works. On our next one here on point H, we have an x-coordinate of -2 and a y-coordinate of 6. So our angle is equal to the tan inverse of 6 divided by negative 2. And we know, of course, that 6 divided by negative 2 is just negative 3. Notice that our x-coordinate is negative, so we're going to have to add 180 degrees to get this angle. So let's do that. We have tan inverse of negative 3, and we're going to add 180 degrees to it. And that gives us an angle of 108.4 degrees. So theta is 108.4. Okay, now to find our radius, we're going to use our equation of our circle, that x squared plus y squared equals r squared. So using our coordinates here, we have negative 2 squared plus 6 squared equals our radius squared. So 4 plus 36 is equal to r squared. That comes out to be 40, so square root of that is square root of 40. And again, let's find that value. Square root of 40 is 6.3. So our ordered pair here that we're looking at is 6.3 for the radius and 108.4 degrees for the angle. Okay, let's check that on our graph and see whether or not that makes sense. Let's take a look at the point negative 2, 6, and our polar coordinates 6.3, 108.4 degrees. Okay, so first let's do the negative 2, 6. As we're going, negative 2, we go to the left 2. So we're 2 circles out along this horizontal point on our graph, and 6. 1, 2, 3, 4, 5, 6 this direction. So we are somewhere right about there. And let's see if our angle is the same. Our polar coordinates that we were looking at, again, were 6.3, 108.4 degrees. So let's go out 6.3, 1, 2, 3, 4, 5, 6.3, and 100 and, what was it, 4 degrees? 108 degrees. Yep, that looks just about right. So there we are. Okay. Now let's do one last example, converting to coordinates there. Our angle theta is tan inverse of the y over the x, so negative 3 over negative 5. And since the x coordinate is negative, we're going to add 180 degrees to it. So theta is equal to tan inverse of 3/5 plus 180. Okay. So tan inverse of 3/5 plus 180 gives us an angle of 211 degrees, 211.0. And then our radius, we have x squared, negative 5 squared, plus y squared, negative 3 squared, equals our radius squared. So 25 plus 9 is 34. And we do the square root of that. Square root of 34, 5.8. So our polar coordinates are 5.8, 211 degrees. Okay, again, let's check those. Let's see if those make sense. We're going to look at the rectangular coordinates, negative 5, negative 3. So negative 1, 2, 3, 4, 5 going in this direction, and 1, 2, 3 going here. And these two meet right about there. In our polar coordinates, we had 5.8. So 1, 2, 3, 4, 5.8. And we're going to take this circle all the way around to 211 degrees, which is right there. There's 210, here's 211 just past that. Okay, so those are polar coordinates. That's our lesson that we're working with today on polar coordinates. We can convert from either rectangular to polar or polar to coordinate, polar to rectangular, and we can graph points.